I'm going to draw here what we had up on the board the last time to emphasize what we mean by an exocrine gland. And we'll walk through the idea of the exocrine gland being composed of epithelial cells. Those epithelial cells are organized into a surface epithelium, a duct epithelium, and a secretory epithelium. But these epithelial cells will obey all the rules of an epithelium we've talked about so far. That is, they'll have an orientation, they'll sit on a basal lamina, and they'll just be modified slightly as to whether or not they're surface, duct, or secretory. What I want to spend more time on, however, is this idea of connective tissue. We said that there were 4 types of tissue. There was epithelium, connective tissue, muscle, and nerve. Well, this second set is the connective tissue. Now, all connective tissue cells originate as something called mesenchyme. The mesenchyme is a name for a certain set of embryologic cells that are destined to give rise to different kinds of connective tissues. We know now that if we take those mesenchymal cells and we treat them slightly differently with different kinds of growth factors, turn on slightly different genes, that those mesenchymal cells then can be fated to become fibrocytes, chondrocytes, osteocytes, or hematopoietic stem cells. The fibrocytes generate something known as connective tissue proper. Connective tissue proper includes things like ligaments and tendons, and we'll see today the dermis of skin. The connective tissue proper are making connections largely. The cartilage is produced by chondrocytes. The cartilage is a true tissue. It is composed only of chondrocytes. It doesn't contain a blood supply. And we'll use cartilage as an example of a tissue, and we'll emphasize the hallmarks of tissue by saying that regardless of which type of which type of cartilage we're talking about, no, you can't do that. We have to have people sit there. Is that okay? All right. So the second type here is cartilage, and the reason I want to emphasize the cartilage is that it has all the hallmarks of each type of connective tissue. And what I mean by that is we'll see that they're chondrocytes, separated by large spaces, and what's filling in the spaces between the chondrocytes is going to generate the cartilage. There'll be extracellular proteins. And will distinguish one kind of cartilage from the other, not by the cell type that secretes them, but rather by the proteins that the chondrocyte has secreted. So we'll see there's fiber cartilage, which is rich in collagen, elastic cartilage, which is rich in elastin, and then hyaline cartilage, which is enriched for something called GAGs, or glycosaminoglycans. Bone, too, is a connective tissue. It obeys the same rules. Widely scattered cells, now in the form of osteocytes, that have spun out an extracellular matrix. What distinguishes bone from the others is that it, in addition to secreting proteins like collagen, it secretes calcium phosphate. It mineralizes bone. It makes bone hard. That hardness of the bone is because the osteocytes, in addition to secreting proteins, will now secrete calcium phosphate. Blood of the 4 is the one I find least obvious, but it still obeys the rules. If you think about blood, what blood is individual cells floating in plasma. Well, plasma is an extracellular series of proteins. It's mostly water, but about 8 to 10% of it is extracellular proteins. So we again see cells floating in an extracellular matrix of proteins. Now, it's true, in blood, these proteins are soluble until something changes and they form a clot, and then they form a fibrous clot. But nonetheless, the rules are the same in all cases, and we'll emphasize these rules and what holds all of this together. So we've discussed what makes cartilage different. And here now we want to talk about skin as an organ. Now what we're going to think about is how we bring together tissues to make a proper organ. We said that the definition of a tissue is a structure composed of similar cells generating a similar function, performing a similar function. But now what we're going to do is start mixing and matching things to generate an organ. And the first organ we're going to talk about is skin. Because skin is an epithelium plus connective tissue proper. The epithelium is going to be something known as the epidermis, and this epidermis is going to be composed of keratinocytes organized in a stratified squamous epithelium. The stratified squamous epithelium of the epidermis sits on the dermis. The dermis is generated by fibrocytes. It's connective tissue proper. And if you look at your shoes and they're leather, that's the dermis of a cow. We harvest the hides of animals and then we treat them chemically. We tan those hides, and what we're tanning is the extracellular proteins that comprise the dermis. Then what we're going to think about is the organization of these. We'll see that the epidermis, as the name implies, epidermis, it sits on the dermis. It's composed of a series of epithelial cells. These epithelial cells generate a lot of keratin because they have lots of hemidesmosomes and desmosomes, and that keratin then is the intercellular protein that characterizes the keratinocytes. The fibrocytes have again done their job. They've spun out this extracellular series of proteins, and they have generated the dermis. But one of the hallmarks of this is that these cells are continually dividing and sloughing off the top. So when you look at your skin, what you're looking at is skin cells that used to be down on the basal lamina, maybe a couple of weeks ago. Beneath that, though, the fibrocytes are fairly permanent, and they don't change much, they don't turn over much, and their secretions in terms of the extracellular proteins don't turn over much either. One of the characteristics of skin is that the blood supply is confined to the dermis. It's confined to the connective tissue proper, and as such, now all of the oxygen, all of the nutrition that is available to the epithelial cells has to come from these underlying layers. One of the characteristics of all epithelia is that they are not vascular. They don't have blood supply to them. The blood supply is effectively indirect. The blood and the oxygen and the nutrients from the blood have to diffuse some distance to get to these epithelial cells. And then once we've laid out the structure of skin, we'll come back and talk about this other character, the melanocytes. The melanocytes are not keratinocytes. They're a different embryological origin. And what they do is they secrete pigment that gives skin and hair its color. And we'll talk about that in some detail. And then we'll talk about appendages of skin, which will be glands, hair, nails, in the case of animals, hooves.